Hello and welcome to Recyclist. My name is Eric Provost, and today I have the great honor of being joined by a very special guest. So please help me welcome to the show right now the Chief Operating Officer of Econward Tech, Mr. Joe Ayala. Thank you so much for joining me today, sir.
Hello, Eric. How are you?
Doing very, very well. We are speaking right after the Memorial Day holiday weekend, so I hope the holiday weekend treated you well, sir.
Yes, sir. It was very restful. Thank you, and I hope you had a good weekend with your family as well.
I did too. Thank you very much for asking. I know that you tend to travel a bit with all of your duties. You tend to hop between California and Madrid, just two very famously miserable places to be. So it must be a terrible job that you have, sir.
Indeed, indeed. I'm actually just coming back from Madrid. I spent the last week with the Spanish team, and I just arrived back on Sunday.
But the reason that you are constantly traveling is your work with a certain company. We just mentioned it a few seconds ago, Econward Tech. So, for those who may not be familiar, sir, can you please kind of introduce yourself to the people and what Econward and Econward Tech is?
Yes, my name is Joe Ayala. I am the Chief Operating Officer for Econward Tech LLC, which is the US subsidiary for Econward Tech, our company in Spain. The company develops technologies for to help with organics diversion. In particular, we have a technology called BIOMAK, which does thermal hydrolysis. And I know that is a bit of a mouthful.
Yeah, we're certainly going to get into that here in just a moment. I can't wait to talk about that. I will say why Econ Ward, formerly now on, why Econ Ward Tech uh, decided to get into this realm of decarbonization and waste management and things like that. What was the idea?
Our mission, I think, and this comes from the owners of this company, is to contribute to a better world, I guess.
Yeah,
And they believe that this is what we all should be focusing on, and they found their way to contribute is to bring in technologies that help decarbonize our planet.
yeah, and you have a pretty long history within this industry already. Like I said, you worked with the company back when it was called Now On. You formerly have a company called Vartsila, who also worked in the same space. So, what are some of the biggest takeaways and lessons learned that you've kind of brought with you up to this point in your career?
The biggest lessons, I think, decarbonization, you know, is a priority, but not always. It can be done in a cost-effective way. So keeping an eye on the execution of these projects and how we can make it in a way that is financially viable. I think that is the biggest lesson is how to help the environment to be sustainable, but also in an affordable and scalable way.
Yeah. And I've already kind of brought attention to the fact that you work in California, but California, I feel like, is a very thought forward state when it comes to being conscious about the changing waste and energy landscape. So, and I know you guys recently gave a talk at, I believe, a SWANA conference in regards to some new legislation that recently came out through California itself, SB 1368 or 1338 or something like that. So,
1383, yes.
1383, I apologize. So, what's it like working in California in regards to the legislation and the industry and trying to push this forward?
Yeah, look, California is a very progressive place in
Yeah.
one of the, I would say, the most progressive parts of the world, right? Um, the legislation SB 1383 is the law of the land at the moment, and mandates a 75% organics diversion from landfills from previous levels, and it is a work in progress, like everyone in the sector, not only in the renewable energy sector but also in the waste, solid waste and wastewater sectors. They will tell you it's a work in progress. It's not without challenges, and some of the challenges are how to make it work economically, right?
Yeah. And speaking of making it work economically, we've already talked about waste diversion a little bit. Your company specializes in that. I think it's time for us to really get into the BIOMAK system, your company's big calling card, and what you guys are really bringing to the table when it comes to this industry right now. Can you let us know what this BIOMAK system is?
Yes, BioMak is a thermal hydrolysis technology designed and built by Econward Tech. Um, we can look at thermal hydrolysis as a big, gigantic industrial capacity pressure cookers that it is composed of four autoclaves and built in a way that becomes a continuous autoclaving system. So it's the first of its kind. It's the first continuous autoclaving system applied to municipal solid waste. Our focus is on capturing the organic fraction of municipal solid waste.
And so, what's the idea behind that? Who had this idea? Hey, let's take all this trash and let's put it in a pressure cooker. What's the benefit to doing that? What is thermal hydrolysis really?
Yeah, look, thermal hydrolysis is done in autoclaves, and the use of autoclaves for solid waste is not a new idea. We could see, we could find, I think, papers and materials from easily 40 years ago talking about the benefits of pressure cooking, if you wish, solid waste. What happens is that solid waste is composed of an organic fraction and a non-organic fraction. Those organics are mostly carbohydrates in waste, in garbage. Think of your banana peels and rotten produce in there. Um, and when that material is subject to heat, steam pressure, and heat, it basically breaks. So, in I'm a chemical engineer and I like talking chemistry, but for the layman, is think of your banana peel becomes broken into smaller pieces, and those long those long carbohydrate molecules become smaller, and they break into sugars. That's what the principle of hydrolysis does. And hydrolysis can be done biologically or it can be done thermally. What we do is to apply heat to 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 obtain a hydrolyzed material, and there are a couple of benefits when you do that. The first benefit is that that material now easily separates from the non-organic fraction, and this was discovered, as I said, many decades ago. So basically, thermal hydrolysis enables the separation of the organic fraction from the non-organic fraction in municipal solid waste.
And what is the major benefit of doing that really? Why should people be interested? Why should we consider doing that with our organic waste or
Because
with our waste in general?
yeah, and that is an important point, Eric. we are not focused on um, what people understand or what the industry understand as organic waste. So we are not focused on food waste or green waste. We actually focus on MSW, and the that material, once the organics are separated, they are primed for biological processes such as anaerobic digestion or even fermentation. Because think of BIOMAK as a sugar extraction machine from 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 garbage. So if you could have a machine that can extract those sugars, then those sugars will be primed, and they are truly glucose and arabinose and sugars. They will be primed for other biological processes, um, some of which can create fuels, right?
Yeah.
And in the case of anaerobic digestion, it generates biogas, which contains a very valuable fuel called biomethane.
Yeah, I do think it's important to note that we do talk a lot about anaerobic digestion, renewable natural gas here on the show. The biomac process, you guys are not directly creating biogas through the hydrolysis. You are not directly creating that biomethane.
Correct, correct. We the biomax system, this continuous autoclaving system that hydrolyzes the waste, generates a hydrolyzed biomass that then is used for biological process such as anaerobic digestion. But yes, that's correct. We do not um, design the anaerobic digesters or the systems that follow it.
And for the biomax system, obviously, we've talked a lot about what has happened with the organic component of MSW, municipal solid waste. Do you guys separate out the inorganics, or do you
Yeah.
accept just the entirety of municipal solid waste? You guys do separate out the inorganics?
Yeah, so it works like this. So we will think of 100 tons of municipal solid waste. We will get all of it inside the machine. We will thermally treat it. And the machine, by the way, just uses steam. There is no other chemicals here. And the pressures that we use are very low in terms of autoclaving. We only use, think of 30 to 50 or 60 psi, so not very high pressures. So we uh, take all of the garbage, put all the garbage in a continuous fashion. We'll take this 100 tons and think of, then it will go into a simple vibrating screen where the organics will be separated from the non-organics. So and those two fractions are very valuable commodities, right? The organic fraction because it goes to biogas, but the non-organic fraction is also extremely valuable because this non-organic fraction now is light, is dry, is odorless, has a very very high BTU value, meaning energy value in terms of things that you can do, and we can now put it through mechanical separation systems where plastics and aluminum and ferrous metals can be separated, and those are extremely valuable waste streams that would have otherwise been lost if we would have sent these 100 tons to a landfill. Right now, we have 50 tons of organics and 50 tons of non organics, assuming a 50% organics composition. But both streams are very valuable. We have created two extremely valuable commodities just by being able to hydrolyze this waste in a thermal machine. Yeah.
And when we talk about the biomass that you create, looking on your website, econward.com, you guys say that the resulting biomass that you guys produce has more than a 98% organic compound. You guys claim that you can double biogas production
Yeah,
from biogas plants.
yeah. The reason for that is that the material, the hydrolyzed biomass, contains a high percentage of volatile solids that when that in anaerobic digestion they degrade to over 80%. That is the volatile solid degradation is a technical term, but that in essence means that it produces much more biogas. Think of feeding a biological system, a feedstock that is cooked versus a feedstock that is uncooked. So the cooked feedstock will be primed for digestion, and that is exactly what happens.
Very cool. Well, Joe, I am really looking forward to continuing our conversation and learning even more about the BIOMAK system, and we will do that in the very next episode of Recyclist. So, to all of our listeners out there, make sure to stay tuned in for that. But do me a favor before you all leave, make sure to show some love to the company that helps make Recyclist possible, Diamond Scientific. They are an industry leader in gas analysis, instrumentation, and solutions. And if you're looking for a solution like that, make sure to check out diamondsci.com. That's diamondsci.com. Or you can even set up a personalized presentation just by calling 321 223 7500. Once again, my name is Eric Provost. I've been your host, and tune in next week for the conclusion of my discussion with Joe Ayala of Econward. We'll see you then.